getting into ASA congruence rule, let us discuss some special properties of triangles. The first theorem states that angles opposite to equal sides of an isosceles triangle are equal. The proof for the same is as follows. We are given an isosceles triangle ABC in which AB is equal to AC. We need to prove that angle B is equal to angle C. Let us draw the bisector of angle A and let D be the point of intersection of this bisector of angle A and BC. In triangle BAD and triangle CAD, AB is equal to AC, which is given, and angle BAD is equal to angle CAD by construction. Here AD is common. So triangle BAD is congruent to triangle CAD by SAS rule. Therefore, angle ABD is equal to angle ACD, since they are corresponding angles of congruent triangles. So, angle B is equal to angle C. Hence, angles opposite to equal sides of an isosceles triangle are equal. Is the converse true of this statement? Yes. The converse of the statement is the sides opposite to equal angles of a triangle are equal. Now, let us see how we can prove the same. In triangle ABC, the bisector AD of angle A is perpendicular to the side BC. We have to show that AB is equal to AC and triangle ABC is isosceles. Solution for the same is as follows. In triangle ABD and triangle ACD, angle BAD is equal to angle CAD, which is given. Here, AD is common. Therefore, angle ADB is equal to angle ADC, which is equal to 90 degree, which is given as per the question. So, triangle ABD is congruent to triangle ACD by ASA rule. And AB is equal to AC because congruent parts of corresponding triangles are equal. Or triangle ABC is an isosceles triangle. Let's discuss another criteria for the congruence of triangles. The ASA congruence rule, which states that two triangles are congruent if two angles and the included side of one triangle are equal to two angles and the included side of the other triangle. So, look at the two triangles in there, where you can see two angles and one side is equal to the other triangle. Now, let us see how to prove the congruence criteria. We are given two triangles, that is ABC and DEF, in which angle B is equal to angle E, angle C is equal to angle F, and BC is equal to EF. We need to prove that triangle ABC is congruent to triangle DEF. There exist three cases to prove the same. Now, let us take a look into the first case. Let AB is equal to DE. Angle B is equal to angle E, which is given, and BC is equal to EF, which is also given. So, triangle ABC is congruent to triangle DEF by SAS rule. Now, let us look at the second case. Let if possible AB greater than DE. So, we can take a point P on AB such that PB is equal to DE. Now, consider triangle PBC and triangle DEF. Observe that in triangle PBC and triangle DEF, PB is equal to DE by construction. Angle B is equal to angle E, which is given, and BC is equal to EF, which is also given. So, we can conclude that triangle PBC is congruent to triangle DEF by SAS rule. Since the triangles are congruent, their corresponding parts will be equal. So, angle PCB is equal to angle DFE. But given that angle ACB is also equal to angle DFE, so angle ACB is equal to angle PCB, is that possible even? This is possible only if P coincides with A or BA is equal to ED. So, triangle ABC is congruent to triangle DEF by SAS rule. If AB is lesser than DE, we can choose a point M on DE such that ME is equal to AB, and repeating the arguments as given in case 2. we can conclude that AB is equal to DE, and so triangle ABC is congruent to triangle DEF. Suppose now in two triangles, two pairs of angles and one pair of corresponding sides are equal, but the side is not included between the corresponding equal pairs of angles. Are the triangles still congruent? You will observe that they are congruent because sum of three angles of a triangle is 180 degrees. So, if two pairs of angles are equal, the third pair is also equal. So, two triangles are congruent if any two pairs of angles and one pair of corresponding sides are equal. We may call it as the AAS congruence rule. Now, let us consider a problem. AD and BC are equal, perpendiculars to a line segment AB. Let's show that CD bisects AB. The solution for the same is as follows. In the triangle OCB and triangle ODA, angle BOC is equal to angle AOD because they are vertically opposite angles. And angle CBO is equal to angle DAO because each of the angles are 90 degrees. Also, BC is equal to AD, which is given. Therefore, we can conclude that triangle OCB is congruent to triangle ODA by ASA congruency rule. Also, we notice that BO is equal to AO because congruent parts of the corresponding triangles are always equal. Hence, CD bisects AB. Now, let us discuss the final criteria for congruency of triangles, which is the RHS congruence rule. So, what does that state? As you notice from the figures, if in two triangles the hypotenuse and one side of one triangle are equal to the hypotenuse and one side of the other triangle, then the two triangles are said to be congruent. Let us consider an example to prove the same. BE and CF are two equal altitudes of a triangle ABC. Using RHS congruence rule, let us prove that triangle ABC is an isosceles triangle. Let us draw the diagram according to the question. So, BE and CF are the two equal altitudes of the triangle ABC. Now, let us prove that ABC is an isosceles triangle. The solution for the same is as follows. In triangle FBC and triangle ECB, angle BFC is equal to angle CEB because each angle is 90 degrees and BC is common in here. FC is equal to BE, which is given as per the question. Hence, triangle FBC is congruent to triangle ECB because of RHS congruency rule. Also, angle FBC is equal to angle ECB because congruent parts of corresponding triangles are always equal. Also, AC is equal to AB as angles opposite to equal sides are equal. Hence, triangle ABC is an isosceles triangle. Let us solve another problem which makes use of multiple congruency rules. If triangle ABC and triangle DBC are two isosceles triangles on the same base BC and vertices A and D are on the same side of BC, if AD is extended to intersect BC at P, let's show that the first subpart, triangle ABD, is congruent to triangle ACD. The second subpart, triangle ABP, is congruent to triangle ACP. Third subpart, AP bisects angle A as well as angle D. And finally, AP is a perpendicular bisector of BC. The solution for the same is as follows. Let us solve the first part. In triangle ABD and triangle ACD, AB is equal to AC, which is given. BD is equal to CD, which is also given in the question. And AD is common. Hence, triangle ABD is congruent to triangle ACD according to the SS's congruency rule. Now, let us solve the second part of the question, which says that show that triangle ABP is congruent to triangle ACP. We know that triangle ABD is congruent to triangle ACD, which is proved previously. Also, angle BAD is equal to angle CAD because corresponding parts of the congruent triangles are equal. In triangle ABP and triangle ACP, AB is equal to AC, which is given. Angle BAP is equal to angle CAP, which is proved previously again, and AP is common. Hence, triangle ABP is congruent to triangle ACP according to the SAS congruency rule. Now, let us solve the third part. We know that triangle ABD is congruent to triangle ACD. Angle BAD is equal to angle CAD because corresponding parts of the congruent triangles are always equal. And angle BDA is equal to angle CDA because corresponding parts of the congruent triangles are again equal in this case. Hence, AP bisects both the angle A and D. Now, let us solve for final part of the question. We know that triangle ABP is congruent to ACP, which was proved previously. BP is equal to CP because corresponding parts of congruent triangles are always equal. Angle BPA is equal to angle CPA because CPCT proves again there. Therefore, angle BPA plus angle CPA is equal to 180 degree as they are linear pair. Angle CPA plus angle CPA is equal to 180 degree as angle BPA is equal to angle CPA. Therefore, we get 2 times angle CPA is equal to 180 degree, which implies that angle CPA is equal to 90 degree. Therefore, AP is perpendicular to BC. BC because BP is equal to CP. Now, let us summarize. Theorem 1 states that angles opposite to equal sides of an isosceles triangle are equal. Theorem 2 states that the sides opposite to equal angles of a triangle are equal. ASC congruence rule states that if 2 angles and one side of one triangle are equal to 2 angles and the corresponding sides of the other triangle, then the 2 triangles are said to be congruent. RHS congruence rule states that if in 2 right-angled triangles, the hypotenuse and one side of one triangle are equal to the hypotenuse and one side of the other triangle, then the 2 triangles are said to be congruent.